Welcome to the online classes. In the last week we discussed about integration and some of its way to solve the problems of indefinite integral. We have already discussed about the substitution method, this particular function method, and then the method of partial fraction. Now in this week we are going to discuss about the Ilate rule and then the properties of definite integral. One topic is eliminated from this chapter, which is limit as a sum. So we are not going to discuss that topic for our board's exam, but we will see some of the important properties of definite integral. So in today's class I am going to discuss about the Ilate rule with some examples, some problems. I have already discussed the Ilate rule in the previous section, previous class. So today we will solve some of the examples. So in order to solve a problem having two functions, just like we can say product rule in derivative, we have a rule of product in integration also, which is called the rule of by parts, or we can say the Ilate rule. Now we have a question, integration of tan inverse x. Now this tan inverse x integration is not known to us. We don't have any formula. So what I have done, this tan inverse x is multiplied by 1, because we can multiply any number by 1, the answer remains same. Now this is inverse trigonometric function and this is algebraic function. So this is u and this is v. Now applying the concept of by parts, the formula is first function is as it is, integration of second function minus the whole integration of differentiation of first multiply by integration of second. Whatever comes after solving this, it should be integrated again. I am again telling you the formula, please see it very carefully. First function as it is, integration of second function minus the whole integration of product of these two things. These two things include differentiation of first multiply by integration of second. Now this will give us I is equal to, since it is integral, we are applying I here. Integration of one is x tan inverse x minus differentiation of this is 1 upon 1 plus x square. Integration of this is x. So this will become x upon 1 plus x square, and this is x tan inverse x. Now take this as I1 and solve it individually, and at last just merge them to get the final answer. So now this is I1. We can solve this by using the substitution method. Put this as t. The differentiation of x square is 2x, so dx is dt by 2x. Applying here, x and x eliminated, dt by t give us log. Half log base half log t. So the value of t is 1 plus x square substituted. Now this is merging here to get the final answer, x tan inverse x minus this complete function, half log 1 plus x square plus c. So in order to solve a problem in product, in multiplication having two functions, we can apply the concept of by parts, in which we need to understand the formula very carefully, and then we can solve problems. So I am going to tell you 2-3 more questions which will help you to understand the formula very carefully and very easily. Now we will see one more problem based on the by parts rule. Question is integration of x cos inverse x divided by under root 1 minus x square. Now this is a format question. It will come in two ways, either the cos inverse or the sine inverse. Also it will come in tan or cot. So the pattern is, we have to observe this 1 minus x square. So the differentiation of x square is minus 2x. Now we have already x there. So what I have done, I have just multiplied and divide that particular x with minus 2. So I got cos inverse x as it is, multiplied by minus 2x divided by this function, and this minus 2 is also here. So what I have done, dividing and multiplying the whole expression by minus 2. Now this complete is taken as u and this complete is taken as v. Now applying the Ilate condition, first term as it is, integration of second minus whole integration of product of this, that is differentiation of first multiply by integration of second. Now this integration is solved by the method of substitution, putting this as t minus 2x dx equal to dt, dx equal to dt by minus 2x, which will eliminate that. We get 1 by root t. Integration of 1 by root x dx is 2 root x. So this is 2 root t. Now substituting this value in place of integration, here also we get this 2 under root 1 minus x square cos inverse x. This both terms are eliminated and we get minus minus plus 2 dx. The integration of this is 2x. Now since this is 2, when it multiply by both the terms 2 and 2 are eliminated, so we get minus of this function plus x plus c. Now in this question the most important thing is to understand the pattern. If we have sine inverse also here, we have to do like this. It will make our question easy. There are many other methods also to solve this, but this one is the most easiest one, in which we need to just apply this concept, dividing and multiplying by minus 2. And then also integration of this should be done, because if we are not doing the integration, we are not showing the integration, teacher is not able to understand how we applied this to this. So you should do each and every step, don't try to leave out any step, and each and every formula should be kept in your mind. Now we will see one question related to the exponential and by parts related. Now we have one special property related to exponential, which is if the integration is of this format, integration of exponential e to the power x multiply by a function plus the derivative of that function. If the question comes in this format, the answer is e to the power x multiply by the function EX-fx plus c. So we need to see in case of exponential problems either this function is coming or not. So we have a problem e to the power x multiply by 1 plus sin x upon 1 plus cos x. Now using the concept of sine to theta and cos to theta in terms of half angle, one is sine square theta plus cos square theta, which is x by 2 x by 2. Sin x is the formula of sine 2x in terms of half angle, 2 sin x by 2 cos x by 2. This one is also sine square theta plus cos square theta, and this is cos 2x in terms of half angle. So this is cos square x by 2 minus sine square x by 2. Now they are eliminated. In the above I got a formula a plus b whole square, and down I got 2 cos square x by 2. Removing this 2 to the outside of the integration, I get 1 by 2 integration of e to the power x sin x by 2 plus cos x by 2 upon cos x by 2 whole square. Now dividing that, we get 10x by 2, and this is 1. So I got 10x by 2 plus 1 whole square. Now expanding the formula a plus b whole square, which is a square plus b square plus 2ab. So this is 10 square x by 2 plus 1 plus 2 10x by 2. This becomes sec square x by 2, and this is as it is. Now this comes in this format. If we apply this as a function, the differentiation of this is going to be sec square x by 2. So the final answer is e to the power x f of x plus c, which is e to the power x. Fx is 2 10x by 2. 2 and 2 eliminated. The answer is e to the power x 10x by 2 plus c. So in case of exponential problem, we need to just focus on this format. Either the problem is coming in this format or not. If it is not, we can just simply solve by the method of Ilate rule or by parts. So hope you understand the concept of Ilate and the concept of exponential format. Try solving 7.6, and in the next class we will discuss about the properties of definite integral, because we have to eliminate one of the topics, which is limit as a sum. So we will move on to the properties of the definite integral, as we have just finished up all the topics based on indefinite integral, and after completing the properties we will solve problems based on the definite integral. The chapter is very important. It will come around 10 to 12 marks in the board examination. The problem will be from either of the topics, either the substitution method or the partial fraction, and the most important is this Ilate rule. So you need to practice as much problems as you can and try to find out all your doubts and send to me. And if you still have any doubt, you can call me and you can We can have a doubt class also in our next session. Till then, you try solving the problems and try to finish all your work. Thank you.